Okay, so we're going to work a little more with applying the first derivative, but now we're going to remember what to do when we have functions that have discontinuities. All right, so we have our function here, which if we look at the denominator, there's going to be some values in the denominator that are going to give us some discontinuities. So to find those discontinuities, if I take my denominator, set it equal to 0, and I solve it, I'm going to factor it. I get 2 discontinuities. So I know at -3 and +3, there are some discontinuities on the graph. All right, so let's take the derivative now. All right, so if you remember, this was the annoying derivative because you either had to know the quotient rule or you had to remember to pull the terms out of the denominator using a negative exponent. All right, so this is the product rule. So I have to take the derivative of the first guy, which just gives me 2x. All right, now I take the derivative of the second guy. So I drop the -1 in front. I subtract 1 from the exponent. And then I take the derivative of the inside, which is 2x. Okay, so now to find the derivative using the product rule, I take the derivative of the first guy times the derivative of the second guy plus the derivative of the second guy times the first term. So I have -1 times 2x times x squared, so I have -2x to the third. Okay, so this is our derivative, but it's a little annoying to work with, so we always take these two terms and we pull them together. So to do that, I'm going to drop the x squared minus 9 back into the denominator. And I'm going to drop the x squared minus 9 quantity squared into the denominator because the negative exponent tells us to pull it down. All right, so now I need a common denominator. This has one single x squared minus 9, and this has 2 x squared minus 9s. So this needs an x squared minus 9. If you put it in the bottom, you have to put it on the top. All right, so now we can work on the top. We have 2x to the third minus 18x plus negative 2x to the third over our common denominator, which is x squared minus 9 quantity squared. All right, so if you notice, we have like terms here. They eliminate each other. So my first derivative in its simplest form is negative 18x over x squared minus 9 quantity squared. All right, so that's my first derivative. So that was a lot of work, but I'm not even done yet because now I have to find my critical numbers. So I have to take my first derivative and I have to set it equal to 0. Okay, so I have a fraction equal to a number. I can put the LCD on both sides, or I can put this over 1. I can cross multiply. I get negative 18x times 1 is negative 18x equals 0 times this quantity gives me 0, so that my critical number is 0. All right, so now we have actually 3 important numbers because we have our critical number, and then we also have 2 numbers that give us discontinuities on the graph. So we actually have to break up our interval using all of those numbers. The discontinuity of -3, the 0 for the critical number, and the 3 for the other discontinuity. So I have 1, 2, 3, 4 intervals I'm testing. I'm testing negative infinity to -3. I'm testing -3 to 0. I'm testing 0 to 3. And I'm testing 3 to infinity. All inside of my first derivative. All right, this interval, I'm going to pick actually negative 10 because the first derivative is kind of funny looking. It's just going to be an easier number for me to work with. So I have negative 18 times negative 10 over negative 10 squared minus 9 quantity squared. All right, so in the top I have a positive number divided by a positive number, which means that this whole thing is positive, which means my function is increasing on this interval. All right, now negative 3 to 0, I'll pick 1. Oh, actually, I have to do negative 1. Okay, so evaluating negative 1 into the first derivative. I get a positive number over positive number, which means the whole thing is positive, which means the function is increasing. All right, now I will test 1 in this interval. Okay, plugging 1 in, I get a negative over a positive, which gives me a negative, which tells me that I'm decreasing. All right, and then lastly, I'll pick 10 in this interval. All right, I got a negative over a positive, which means I'm negative, which means my graph is decreasing. So notice there's no change over here. So remember, this was the discontinuity of the asymptote. So on both sides of the asymptote, I'm increasing. And then I go from increasing to decreasing here. So that's going to represent a relative maximum. And then I go from decreasing on this side of the asymptote and decreasing. So I know over here is my only relative extrema. So I'm now going to take x equals 0, and I'm going to plug it into the original function. Luckily, 0 is nice and easy because we have 0 on the top over negative 9. So that entire quantity is 0. So my relative maxima is 0, 0.